Hello and welcome to the podcast on Unit 12. Today we're going to be talking about Section 25.1, which is nuclear radiation. I'm Mr. Sakaguchi.
And I'm Mr. Lin.
And let's get going here. So one of the things we wanted to do is we wanted to compare and contrast chemical and nuclear reactions. So you see some of the aspect of chemical reactions on the left side and the nuclear ones are on the right side. So just to briefly kind of run through chemical reactions, they occur when bonds are broken and reformed, or form new ones. Atoms remain unchanged, so atoms are what they are. They don't become anything different. These only involve valence electrons. Energy changes are usually associated with these chemical reactions in some sort of way. And reaction rates are influenced by temperature, pressure, concentration, catalysts. And these are things that we've talked about in previous units.
Whereas with nuclear reactions, you have different things to witness. First up, they occur usually just with the nucleus, and when a nuclear reaction occurs, the nuclei emits or shoots out a particle or ray. The atoms are converted from one element into another type of element because of the change in protons. They involve all subatomic particles, protons, neutrons, and electrons, and then there's usually a large energy change associated with it. And another thing to notice is that during a nuclear reaction, they're not affected by temperature, pressure, or catalysts because it doesn't involve anything with the electrons as far as bonding is concerned. So none of those things affect it.
Right. In terms of discovery of radioactivity, there's some scientists you should be aware of. This gentleman with this fantastic beard right here is William Roentgen, and he was the fellow who discovered X-rays. Henri Becquerel, with his fantastic mustache, even though he's bald, discovered radioactivity.
And then we've got Marie Curie and Pierre Curie, the husband-wife duo that got a Nobel Prize. They were the ones that discovered the source of radioactivity and also a couple of elements that are named after them too.
And let us move on. We've gone over this in the previous podcast, but just as a quick rehash, there are different types of radiation. These are the most predominant types. There are definitely other ones that we'll introduce a little bit later in future podcasts. Radioisotopes are isotopes that have unstable nuclei and as a result emit radiation. The most common types of radiation are alpha, beta, and gamma.
Now, these were discovered by Rutherford, and a way to separate between the three types of radiation is how they're affected by magnetic fields. So as you can see in the diagram below, you've got the beta rays, which will shift towards positively charged fields. You've got your alpha rays shifting towards the negatively charged fields, and then gamma rays not affected at all. Now, these have to do with the particles themselves, because beta rays are essentially electrons and alpha particles are helium nuclei, which is just positively charged because it's protons and neutrons only.
That's right. In terms of some of the general properties, some of these we've talked about already. In terms of penetrating power, alpha particles are the weakest. They can be stopped by like pieces of paper in your skin. Beta particles have slightly more of an ability to penetrate. They can go through paper and skin, but are stopped by sheets of metal.
And then lastly, we've got our gamma rays. It shows here about a few inches of lead. A better, more graphic example would be a solid foot of concrete. So you may have seen video footage of old nuclear testing where the scientists are hunkered inside of a bunker. That's like 2-3 feet of concrete, and some of them still got radiation poisoning.
Mm-hmm. X-rays are another form of radiation. They're a lot like gamma rays in the way that they're energetic, and that it's just energy and no charge or particle associated with them. But they're not produced by radioactive sources.
Yeah, instead these are generally emitted just by materials that have an excited electron state. So this is sort of similar to back in what was that, Chapter 4 or Chapter 5, where we're talking about atomic emission spectrum. When you energize things and then you have the excited electron, X-rays can also be emitted as well.
Mm-hmm. And that's it.